Okay, so for the first part of the session, what we're going to be having them look at is the sums of and the first n integers.
Mm-hmm.
So what I'm thinking is have these already arranged and have 6 different stations,
Okay.
and not just looking for what the areas would be. Here we're back to thinking about areas, not volumes, just looking at it top down. By the way, is there something I'm missing on one of these?
Yeah, there is. Let me grab it.
1, 2,
There's
3,
2
4, 5. So we need one more here and one more here.
Actually, so we can fix that real quick.
Yep. It didn't look like a triangular number the way the rest of them did. Okay. So rather than just getting what the total area is, adding that up real quick in their heads to get them to be looking at the rows. 1 plus 2, 1 plus 2 plus 3. Again, looking at printing out worksheets that will direct them that way. And probably have talked in advance about what's an arithmetic sequence, what's a geometric sequence. In this case, the common thing being added, of course, is just 1 each time.
Right.
Okay. And then, I'm going to pause this.
There we go.
See that? And then that'll fade out.
Okay.
Okay. So you said this was 3 by 4.
Uh-huh.
Which is 12. How's that compared to the 6?
It's double.
Double again. Okay. Next one, well, that's just going to be 4 more than the previous one, right?
Mm-hmm.
Okay, that's 10. All right, well, I'll do this one, and we can borrow from the others. So let's see here. 1 plus 2 plus 3 plus 4. Let's do it this way if I can. Come on. All right. And now we have a 4 by 5, right?
Mm-hmm.
Which is double the 10.
Mm-hmm.
All right. Want to make a copy of that one?
Sure. You want to switch me?
So what I was thinking of doing was with the originals, before we have them copy and arrange, to have 6 different stations that they'd go around,
Yeah.
realizing that they're doing a sum of n positive integers, that we're doing one more term with each station that they go around, and then I'll have them go around again and have them making the copies, putting them together.
Yeah.
Or maybe like 1 to each station or something like that.
Mm-hmm.
So you made that copy, and we have what dimensions then?
That is 5 by 6.
Okay, which is how much?
30.
30. We had the first 4 there adding up to 10, so that's going to be 15. Versus the 5 by 6. Give me 30, twice as much as 15. Okay, so now that should be 21, right?
Mm-hmm.
Okay. My guess is going to be we're going to have a 6 times a 7, which is 42.
Yep.
Taking half of that would give us the 21.
Mm-hmm.
So let me try that out. Um, Stay. Okay. So that should now be a copy of this one, right?
Mm-hmm.
Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So the prediction was correct. Okay, now by the way, what if you put those together instead of a copy?
What? Oh, nice.
that's-
Oh, you're missing. Wow.
That's the 1, 2, 3, 4, 5, 6, 7 being
Uh-huh.
added up. This is the 1, 2, 3, 4, 5, 6 being added up.
Oh, would you look at that? Nice little box.
What kind of box?
It's a cube.
Well, we're just looking at
Oh,
the top.
sorry, square. It's two-dimensional.
That'll always happen. That could be a little side thing towards the end. But, okay, it is now your responsibility to make that copy
Okay.
of that.
What we got so far? 1, 2, 6, 7. I know you're here thinking. That's so sad. Why they gotta do me like that? Playing with Legos as a kid was so much easier. There you go.
Okay, so rest it right on top just so the viewers can all see
Okay.
Dane or anybody else that happens to stumble across the video. If you take that back apart so that we can see that it was in fact a copy, if you lay it on top of it for a moment. Okay, so each is adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Okay, and putting them together as a rectangle, it looked like what? What are the dimensions?
7 by 7. Right? 1, 2, 3, 4, 5, 6, 7, 8. Nope, 7 by 8.
7 by 8.
Alright,
Okay, so there we go. So this is one higher.
Uh-huh.
I mean, one term more.
Yeah.
So we already had from these up to 21, adding the 7 to all of that, we're up to 28.
Mm-hmm.
And if the pattern's holding true, we should be doubling that to get
56.
56. And you said the dimensions are 7 by 8.
Mm-hmm.
So 56 divided by 2, that is 28.
Yep.
Now, we would express that as n times the quantity n plus 1 all over 2,
Mm-hmm.
where n is the number of terms.
Yeah.
We're always starting with 1, and we're
Mhm.
always going up by 1. So if the first hour isn't up, as I put in the plans that I shared with you on OneDrive, we could have something like, what about 5 plus 10 plus 15 plus 20, etc.
Mm-hmm.
But if it's starting with 1, look at how many things are being added. Since these are all just going up by 1s, then it's going to be number of terms times 1 more than the number of terms
Divided by 2.
In other words, n times n
Yeah.
plus 1. Because since you're starting with 1, your last term would be the nth positive integer.
Mm-hmm.
What else? And as for y, maybe even introduce this idea pretty early on. Well, we're using some smaller examples, but what if you had 50 things to add?
Right.
Or what if it were a case like 700 plus 1400 plus 2100 plus 2800 plus 3500?
Mm-hmm.
And of course somebody, I won't say any names, we know one name already, but somebody might say, oh, that's easy, it's blah, quickly adding up 700 plus 1400, whatever. Let's say, hey, everybody's going to have their limitation of how many things they want to add.
Right.
And in that case, where it was saying 700, see, that was our fourth one.
Mm-hmm.
1, 2, 3, 4. Well, if you factor out of 700, I'm trying to think of what terminology to use with them, but if everything was divided by 700,
Mm-hmm.
then we would have that, and to balance that out, multiply that by 700.
Right.
Okay? All right.